Hello, I am N Hasan from Mano, Hyderabad. Today I'll be speaking on Virtual Observatory and its tools. Astronomy has changed over the years from a data poor to a data rich science. We live in an era of big astronomical surveys. To list a few, we have the 2DF Galaxy Redshift Survey, we have SDSS, the Sloan Digital Sky Survey, Deep 2 Redshift Survey, SAGES Legacy Survey, TUMAS, Gaia, and so on. It has become essential for astronomers to handle the big data sets and interpret the complex astrophysical problems by using sophisticated statistical techniques and technology. From getting data to getting science out of it, we go through a series of processes. We have the data collected from various satellites, various observatories, and so on. From this data, we select what we are interested in. We have the target data. We do some processing, pre-processing to get some processed data, apply transformations, analysis, and see patterns in it. And we interpret these patterns to get knowledge. To make this process simple, virtual observatories is playing a very important role. So before we come to that, what is Astronomy Data Archive? Astronomy data archives are organized, systematic ways of disseminating information about the celestial objects. Today, these archives are into terabytes or sometimes even to petabytes. So, International Virtual Observatory Alliance was established in 2002 to facilitate international coordination and collaboration for enabling global and integrate access to data gathered by astronomical observatories. These virtual observatory members are Argentina, Armenia, UK, Australia, Brazil, China, Chile, Canada, European Space Agency, European Virtual Observatory, German Astrophysical Virtual Observatory, Hungarian Virtual Observatory, Japanese Virtual Observatory, USA National Virtual Observatory, Observatory Virtual France, Russian Virtual Observatory, Spanish Virtual Observatory, Ukrainian Virtual Observatory, Italian Virtual Observatory, and Indian Virtual Observatory in India. The Virtual Observatory is a collection of interoperating data archives and software tools which utilize the internet to form a scientific research environment in which astronomical research programs can be conducted. A virtual observatory is a collection of interoperating data archives and software tools which utilize the internet to form a scientific research environment in which astronomical research programs can be conducted. As a real observatory consists of telescopes and each observatory with a collection of unique astronomical instruments, the bureaus consist of a collection of data centers, each with unique collections of astronomical data, software systems, and processing capabilities. The main goal is to allow transparent distribution and access of data worldwide. This allows scientists to discover, access, analyze, and combine nature and lab data from heterogeneous data collections in a user-friendly manner. The International Virtual Observatory Alliance is a standard body created by the virtual observatory projects to develop and agree the vital interoperability standards upon which VO implementation is constructed. I would like to give a slide on Virtual Observatories of India. The Virtual Observatory of India project is a collaboration between IUCA and Persistent Systems Limited, Pune. This project is supported by the Ministry of Communication and Information Technology, Government of India. And the VO India project aims at developing free software for astronomical data analysis and visualization. The notable tools developed by VO India is Voplot, Mosaic surveys, and Vostat. Vostat has been developed along with collaborations from Penn State University. So Vostat is a simple user interface and a few R routines for astrophysics. As we proceed ahead, we will see these in detail. So VO basically is interested in doing multi-wavelength astrophysics, archival research, survey astronomy, temporal astronomy. The basic aim is to create a platform where all these things can be done in a simplified way, and the tools would be available for everyone around the world who are interested in using these big data archives. VO project plan is to create these tools for literature survey like the ADS, archives, to have catalogs like Vizier and data archives, tabulations for which they have developed the Topcat, and visualization of these objects, which is the ALADDIN. And like I mentioned, there's interoperability. There's a connection. All these things talk to each other, and data can flow from one application to another, and so on. The bio innovations are the FITS data format. Yeah, FITS stands for Flexible Image Transport System. They have defined protocols like Simple Image Access Protocol, SIAP, Simple Spectral Access Protocol, SSAP, Astronomy Data Query Language, ADQL, BO table formats, and table access protocols. So essentially, BO defined protocols, defined rules so that images can be transferred from the observatory to the users in certain specific formats, in standards, which lived up to certain standards. Same way, rules of sharing data in tables, rules for defining query languages, right? Making a platform which is simple and accessible to all, right? And also have certain standards and protocols for how to access tables and so on. The tools which they have developed are extremely useful, and as we proceed, we will see these in particular. We have VO table, which displays and analyzes the tables, VO plot and Topcat. We have VO stat. We have ALADDIN and ESA Sky used to display images and for analysis. We have VO spec and VO and spec view. These are the standard display tools for downloaded data spectrum and for the analysis. Data visualization tools like ALADDIN, it's an interactive software skies atlas. Skyview, it's used for generating images of any part of the sky at wavelengths in all regime, from radio to gamma rays. We have these wonderful plotting tools like Topcat, which is an interactive graphical viewer and editor for tabular data. Voplot, a tool for visualizing astronomical data. VO Megaplot, for handling large number of points in range of millions, similar to the Voplot, and both these tools have still common functionalities. Stills processing of tabular data, the packages has been designed for, but it's not restricted only to astronomical tables such as object tables. VioConvert, a tool for converting files from one format to another. It supports following file format conversion: ASCII to VO tables, FITS to VO tables, and VO tables to ASCII. So let's now look at some of the VO tools. Voplot, for example, it can be downloaded from the site specified here. If you click it, we will go to the site, and you can scroll down, and we have VOCat, VOStat, and so on. And we have Voplot for plotting VO tables. So these are all the different versions. So Voplot 1, a.zip with the user's guide. When was the release? The release dates are here. And don't take the beta versions, take the ones which are tested. And you can download this file and install it and run it. So when you unzip the file and run it, you'll get an interface of this kind. This button helps you open a file either locally from your computer or from a URL or from some other location. For example, I've downloaded the zip file, blew it up, and we have a VO plot here. And here it is. I can click and specify which file name we require and which format we need. So I have some sample files, DSS file, and it gives you the table metadata. What are all the different rows and columns, and you can do plotting. You can change which row against, we have RA versus DEC. You can change to proper motions and plot. You can make it a log plot. You can reverse the scales if you wish. And you can download it in the whichever file format you require. You can save this file and so on. Similarly, you have the cone search from which you can get from the net. We have histograms which you can plot, and 3D plots you can look from different angles. So you can do this with data sitting on your system, your own data files, or files of catalogs which you can get from the net using the different tools. So it's most important that you try these things and download it, unzip it, and look around with this. Coming to Topcat, again a very versatile tool. With click of buttons, you can load data, analyze it. This is the site from which you can download Topcat. And here it is. What is Topcat? The features, screenshots, and you have downloads here. You can go to the jar file. You have Topcat full jar. You require Java Gate to run this, or this is a Topcat Lite. And again, I'll give you a glimpse of how this works. and I have it downloaded here, and Topcat, when I click it, it runs. I open a file, I decide which file I'm looking for. Either I look at the file for a file which is there on my system. I have to specify, if it is not which file, you'll have to specify in which file format it has. These are all the different file formats it supports. For example, the file which I have here is comma separated variable, and I say, okay, I can see the file. It's a simple file which I just made to show you. It's a 3-column, 10-row file, and I can do scatter plots. So I can take what is on the x-axis and what is on the y-axis and plots here. I can add forms, add line to it. I can choose the font of these points, colors of the points, sizes, and so on and so forth. We can do histograms for whichever. We can do histograms and so on and so forth. We can see the statistics of the file. It gives you a big brief summary. For the first row, the mean is 5.5, standard deviation is 2.87, minimum is 1, maximum is 10, and so on for the second row. And extremely useful and versatile application. I can open another file and I can look at the other file too. And this is to match the two. You can define functions, you can plot. So when we have loaded these two tables, I can do a matching, and so I specify which one I have, which are the two files, and when I match them, it shows you there are 7 pairs found which are same. It creates a new table, match table with table 1 and table 2. And this is the table of match data. This is especially very useful when we have very large tables with thousands of rows and columns, and you want to compare how many rows are similar or so on. You can define subsets from this, have multiplots and various things, which we shall see as we proceed ahead. So, going ahead with the next one, Vostat. There are 2 versions. You can download it from VOI India, the same site which I had shown for Voplot. But to run it locally, you have to install R. The other easier way of doing it is to use this Vostat, the web service. So Vostat web service is a statistical web service that lets you analyze your data without having to download or install any software. One has to upload the data to the Vostat server at Penn State University and download the results. So here's the link to that location. You open it and go to the Penn State site, and you can start using Vostat right away. There are data and tutorial codes, various things, right? So if you just click on start using Vostat right away, it gives you an interface of this kind. First step is to uh, load data. Next, you select analysis, specify what details you want, and then you inspect the output and download it in the required format you want. So either you can download data from a URL, from a local file, or from SAMS. It talks to the other viewer tools like Topcat, Voplot, Vizier, ALADDIN, which you shall see. So suppose we go and choose a file, and say for example I have M file for M3. It's a comma separated variable, so I specify what type it is, then I proceed to the next step. It has downloaded the data and has given, yes, it has RA, DEC, parallax, proper motion, and so on and so forth. You can scroll down and select the tool which you want to, which statistics you want to perform. So just as you see, at click of buttons, we can download data. Yeah, the step 2 is to choose the analysis. You can transform the data sets. We have plots and summaries. Which plot do you require? Whether you want scatter plots, histograms, 3D scatter plots, or whatever. And we are plotting this again, RA versus DEC. Then you go for the plotting of it, and it gives you the plots, and you can download the R workspace and run it later. You can download the file in PDF or EPS format. You can continue for further analysis, and there are a host of analysis which you can do on this data. Some standard tests, regression. Yeah, you can go and see one sample is Z test, paired T test, Wisconsin test. Very versatile tool. You can do regression, you can do multivariate analysis, time series analysis, and so on. So extremely useful tool. And as I said, you go to the website and upload your data set from a URL or from your locally sitting in a system. Step 2 is to specify what analysis you want to do. Step 3 is to give the detailed information. Which columns are you interested in, and in what format you want your output in. Next one is ALADDIN. ALADDIN is the sky atlas. You can get ALADDIN from this site. You can either download ALADDIN desktop, or you can run a preview on your web page itself. You can choose which objects you require, Simbad, Gaia, Tumas. Okay, so if you prefer to run it from a system, you can download ALADDIN, and I have downloaded it here. Again, you require Java for that, and you just click it. and I'm going to run it from my system right here. This is what it looks like. I can uh, give the command here what object or what coordinates am I looking for. Say, for example, I say M13, and it's connecting to the net and getting details. Yeah, so we have this globular cluster M13. It has loaded the DSS image. On the left hand side, it shows you image can be got from 410 sites, how many databases are available, how many catalogs are available, and so on. And you can do various uh, analysis right here. We can stack up different objects from the same region, stack it up and see from different catalogs. So we will see these in detail. It's important to get familiar with it, download it on a system, get different objects, and uh, just look around so that you get, for example, I say M31, Andromeda Galaxy, it is downloaded Andromeda, and so on. You can zoom in, zoom out, and do all kinds of things. And important thing is these catalogs, the sky, these are the STSs, 2MAS, right? From the same region, I can download the STSs ones. I can download the tables. I can use Topcat to analyze it and do a variety of things. Extremely useful. And coming to the next one is Vizier, where you can access the catalogs. And this is the website link from where you can go to the Vizier. And again, you can give the catalog name and find catalog. You can choose which wavelength you are looking for. And there's interoperability between Vizier, ALADDIN. You can cross match. You can do plotting, right? So it's an extremely useful and right. So it has downloaded all the available catalogs. You can choose which one you are interested in, and you can select which are the rows which you require, whether you want all of them or you don't want the name and so on, and then you can download it and analyze it. We submit it and download these catalogs and do analysis using Voplot, Topcat, uh, and so on and so forth. So it's an extremely useful tool. And like I said, there is an interoperability between Topcat, Vizier, ALADDIN, Simbad, uh, Voplot, so on and so forth. The data can be shared between the applications. Different applications we use for different aspects of either doing plotting or getting the catalogs, analyzing the data, and so on. Thank you.